Good afternoon, students. So yesterday we have seen the unit 4. In that we have seen the problem of regarding the coplanar. So one problem we have completed. We have seen the point of intersection and also condition of coplanarity. So yesterday we have seen one problem that is direct with the help of the formula of condition of coplanarity is there, no? That problem we did not the direct one. So just one mistake we have done. See that one. That is to prove that the lines x minus 1 by 2 equals to y plus 1 by minus 3 equals to z plus 10 by 8. So yesterday we have seen this problem. See this one. That is x minus 1 by 2 is equals to y plus 1 by minus 3 is equals to z plus 10 by 8. This we have done now yesterday. Okay. And next one more line is x minus 4 by 1 is equals to y plus 3 by minus 4 equals to z plus 1 by 7. Okay. We have to show that these two lines are coplanar. So we already know the condition for the coplanarity is that is a determinant of x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, M1, L2, M2, N2. It should be equal to whatever the determinant value is there. That should be equal to 0. Then the two lines are called as a coplanar lines. Okay. So direct formula we have to apply here. Yesterday we have seen one more method to solve this problem. So if you see here x1 in for line 1 and for line 2, x1, y1, z1 values are, that is x1, y1, z1 values equals to, it is 1 minus 1 and here minus 10. And for this one, x2, y2, z2 values are 4 minus 3 minus 1. Okay, this are the two values of 1 and 2, two lines. So the condition of coplanarity is, that is x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2. Okay. Now if you substitute the value here, x2 minus x1, x2 here 4 minus 1. Okay. Minus 3 minus of minus is plus 1. Okay. Minus 1 minus of minus is plus 10. That is minus 1 plus 10. Next here, L1, M1, this is the same. 2 minus 3, 8, 1 minus 4, 7. Okay. So yesterday only here, instead of my plus sign, we have used minus, and here also minus. So we got here this as minus 4 and this we have got minus 11. That's why we didn't got it is equals to 0. Here minus of minus, no, so it will become plus. So this is also plus and this is also plus. So when we take this one, this is 4 minus 1 is 3, this is minus 2 and this is 9. So 2 minus 3, 8, 1 minus 4, 7. So if you find the determinant of this one, this is 3 into minus 21. This is minus of minus plus 32. Minus of minus is plus 2. And 7 2s are 14 minus 8 plus 9 into minus 8 plus 3. Okay. So this is 11, no? 11 3s are 33 plus 6 2s are 12 plus here minus 8 plus 3 means minus 5. Minus 5 into 9 means minus 45. If you add both of these two, you will get as plus 45 and this is minus 45. So it is equals to 0. So it is satisfying the condition of coplanarity. So by this method also you can do the problem. So yesterday in second method we have seen that problem. So here only because of here taking plus minus and minus, that was different. These two terms we got same 45, but here we have got 47. Okay. if you'll do this minus of minus, this will become plus and this will become plus. So we'll get both as a 45 and minus 45. And we can cancel out those two. So you'll get the condition of coplanarity, it is satisfied. And the second part is same, finding the equation and also finding the point of intersection. Okay. So this is the problem we are doing on both the two planes when they are in the symmetrical form. So whenever one in symmetrical form and another in unsymmetrical form is given, so how to solve the problem? Today we'll see that one. By this we can complete the fourth unit. We can go to next unit. Okay. So one problem is so one method is you can convert the unsymmetrical form into symmetrical and directly same this whatever the procedure is there yesterday we have done, we can solve through that method. Okay. Or else directly with the unsymmetrical form only you can find the condition of coplanarity and also equation and also the point of intersection. Okay. So for this solving problem also we have two methods are there. Either you can adopt any one method for solving the problem. So this is show that the lines x plus 4 by 3 is equals to y plus 6 by 5 is equals to z minus 1 by minus 2. Okay, this is one line equation and another one is 3x minus 2y plus z plus 5 equals to 0, comma 2x plus 3y plus 4z minus 4 equals to 0. Are coplanar. Find point of intersection and equation of plane in which they lie. Okay. So for this first we have to combine these two plane equations with the help of lambda. That is let first x plus 4 by 3 is equals to y plus 6 by 5 is equals to z minus 1 by minus 2. This is equation 1. Next 3x minus 2y plus z plus 5 equals to 0 equals to 2x plus 3y plus 4z minus 4. So this is line equation 2. Okay. Now third one is combining these two plane equations with 3x minus 2y plus z plus 5 plus lambda into 2x plus 3y plus 4z. Okay, this is the third equation. So combining two plane equations with the help of lambda. Now you separate the x, y, z and constant variables. So if first multiply with lambda, that is 3x minus 2y plus z plus 5 plus 2 lambda x plus 3 lambda y plus 4 lambda z minus 4 lambda equals to 0. Now if you take x common here, it is 3 plus 2 lambda. If you take y common, it is minus 2 plus 3 lambda. Okay. Next, if you take out z common, z you have quotient here 1 minus plus 1 plus 4 lambda. Okay. Constant is plus 5 minus 4 lambda equals to 0. So this is x of this, whatever the quotient is there, that is 3 plus 2 lambda and it is minus 2 plus 3 lambda and 1 plus 4 lambda or x, y, z quotients and last one is the constant value. Okay. Now this plane 3 will be, this plane 3 will be parallel to line 1 if. So here whatever the quotients are there for x, y, z, we have to do with the help in the denominator we have direction ratios, no? So this is LMN, and these whatever the quotients are there, these are L1, M1, N1. So for condition we have for the plane 3 parallel to the line whatever one is there, line 1. Okay. If L into L1, we have one condition, L into L1 plus M into M1 plus N into N1 equals to 0. If you do that condition, we'll get this as 3 into, that means in place of X, Y, Z, we have to substitute 3, 5 and minus 2. Okay. So that is 3 into 3 plus 2 lambda plus 5 into minus 2 plus 3 lambda minus 2 into 1 plus 4 lambda equals to 0. Now you simplify this one. 3 3s are 9, 3 2s are 6 lambda, minus 10 plus 15 lambda, minus 2 minus 8 lambda equals to 0. Okay, now plus lambda minus is there. So minus 2 lambda means 13 lambda. And this is minus 10. So 9 means minus 1, minus 3. So lambda is equals to 3 by 13. Okay. So now we got the lambda value as 3 by 13. Now substitute the lambda value in equation 3. And if you do the cross multiplication and if you simplify that, then you will get one plane equation. Okay. That plane equation is the equation of the plane in which the two lines lie. Okay. And in the question is asking to show that two lines are coplanar also. So whenever we substitute in the whatever the plane we'll get here after substituting the lambda value, in that plane, if you substitute here x1, y1, z1 values, and if you're getting the answer as 0, then the two lines will be parallel to each other. Okay. And similar way for the line 1, if you're taking it is equals to r, and if you do the cross multiplication, and if you substitute that point in any one of the plane, you will get the r value. That r value, when you substitute there, you will get one point. That point is called as a point of intersection. Okay, this is the procedure where one symmetrical and another unsymmetrical form is there. If you find any difficulty in all this process, then you can easily convert this unsymmetrical into symmetrical form, and you can follow the first method. Okay, so if you feel this is easy, you can adopt this one. The thing is, you can do in any method, but whatever the resultant you are getting as an equation of the plane and also point of intersection, both the answers should be same in any method. Okay, if you do in any method, the point will be same and also equation will be same. Okay, so after getting the lambda value, substitute this lambda value in equation 3. Substitute lambda in 3. So 3x minus 2y plus z plus 5 plus 3 by 13 into 2x plus 3y plus 4z minus 4 equals to 0. When you do the cross multiplication, 13 3s are 39x minus 13 2s are 26y plus 13z plus 13 5s are 65 plus 3 2s are 6x plus 3 3s are 9y plus 12z plus 12 equals to 0. Okay. Now 39, here 39x is there plus 6x is there, means you will get 45x minus 26y and 9y is there. So you will get this as 17 minus 17y plus 13 is there plus 12 is there, means 25 plus 25z plus 65 12. 65 12 means 353 you will get plus 53 is equals to 0. Okay, so this is the plane we are getting after combining the two equations, that is the plane equations. When you are combining with lambda and if it is parallel to line 1, then we are getting lambda value, and after substituting the lambda value and simplification, we are getting this plane equation. Okay, now to show that the two given lines are parallel, so this plane passes through here x1, this is x minus x1, y minus y1, z minus z1. Okay, So whatever the x1, y1, z1 values are there, those values if you substitute in place of x, y, z here, if you get that resultant it equals to 0, then we say that two lines are coplanar. Okay. So this whatever x1, y1, z value is there, in that value we are substituting in the equation of the plane which we are getting from the line 1, 2. Okay. So here you write this plane passes through this plane passes through minus 4 comma minus 6 comma 1 on 1, that is 45 into minus 4 minus 17 into minus 6 plus 25 into 1 plus 53. Okay. So 5 4s are 20 is over 16. So minus 180. Minus into minus it is plus 6 7s are 42, 4 6 1s are 102. And this is plus 25 plus 53. Okay. So minus 53 to 55. 50, this is 25 now. Okay, 5 3 8 9 10. So 0 1 here. 5 7 8. So 180 you will get this also. So minus 180 plus 180 we are getting. So the resultant is we are getting as 0. Therefore the given lines are coplanar. Therefore the given lines are coplanar. Okay. Now we need to find the point of intersection. So point of intersection is the same procedure whatever we have done, that is the given lines are coplanar and equation here, and you write an equation of plane containing them means this one 45x it is there, no, that one. Containing them are like it is there, no, in your in the question given two lines containing the one and two is 45x minus 17y plus 25z plus 53 equals to 0. Okay. So we have shown the condition of coplanarity and we have found the plane also. Now the thing is we have to find the point of intersection. So for finding the point of intersection, let first line equation was let x plus 4 by 3 is equals to y plus 6 by 5 is equals to z minus 1 by minus 2 equals to r. When you do the cross multiplication, you will get any point on line 1 is, if you do the cross multiplication, 3r minus 4, 5r minus 6 minus 2r plus 1. Okay. So this is the point which is on the line 1. If it lies on first plane of line 2. Okay. Then what is the first plane of line 2? It is 3x minus 2y plus z plus 5 equals to 0. That is 3 into 3r minus 4 minus 2 into 5r minus 6 plus z is there. Z means minus 2r plus 1. After that plus 5 equals to 0. Okay. In place of x, y, z, we are substituting this x, y, z point. When you simplify this, this is 3 3s are 9r minus 12 minus 10r minus into minus plus 6 2s are 12. So minus 2r plus 5 plus 1 is 6. Okay. 9r here means minus r minus means minus 3r. And minus 12r plus r will get cancelled. Here 6 is there. Plus 6 equals to 0. Implies minus 3r is equals to minus 6. So r will be 2. So r value is 2. Okay. So now this r value substitute here, you will get the point of intersection. Substitute r equals to 2. If you have 1, 2 equation we have done, no? So here third equation is also. So you can take this as 4. Okay. Substitute r equals to 2 in 4. So what you will get? 3 into 2 minus 4. 5 into 2 minus 6 minus 2 into 2 plus 1. So 3 to just 6 minus 4, 10 minus 6 minus 4 plus 1 is equals to 2, 4 minus 3. Okay, 2, 4 minus 3 is the point of intersection for the two given lines. Is the point of intersection for two given lines. 1 and 2. Okay. So like this, you have to solve the problem whenever one unsymmetrical and symmetrical form is given in the question. So first combine the unsymmetrical form with the help of lambda and whatever the element values, direction ratios are there in the line 1. If they are parallel to the quotients of whatever the xyz quotients are there in, when you combine with them lambda, that is L into L1 plus M into M1 plus N into N1 equals to 0. When you substitute there, you will get the lambda value. That lambda value is substitute in the equation 3. Then you will get one equation. That equation is the equation of the plane containing the two lines. And to know whether they are coplanar or not, whatever the first plane line equation is there, that line equation x1, y1, z values, you substitute in the plane. If you are getting the resultant as 0, then the given lines are coplanar. If you are not getting it as not equals to 0, then they are not coplanar. Okay. To find the point, we'll take the line 1 and we equate it to r. And when you do the cross multiplication, you will get x, y, z values. And if you substitute that x, y, z values either in first plane or in second plane, you will get the same r value as 2. So after substituting r in first plane, we have got r value as 2. Again, if you substitute that value in this point, you will get the point. That is r value. If you substitute in the xyz value, you will get 1 point. That point is called as a point of intersection. Okay. So this is the procedure here. This is the 10 marks problem. Okay. So two symmetrical form you may get, or one symmetrical and one unsymmetrical also. Anything you may get on the question for this one. But this is concept is for 10 marks question. So one image of a point P is there. This problem is also for important for 5 marks question. That is, find the image of the point in the plane. So one point will be given. We have to find the image of that point in the plane. Okay. So this is the 5 marks question you have. Find the image of the point Point is 1 comma minus 1 comma 5 in the plane 3x minus 2y minus 4z minus 14. Okay, here P is a point. Here we have one plane is there like this. So this plane is 3x minus 2y minus 4z minus 14 equals to 0. So if you take here any point, so we have to find the image of P is here Q, no? So we have to find the coordinates of the point Q with the help of the point P and also with the help of the plane. 1 minus 1, 5. And here Q we are taking x1, y1, z1. Okay. So R is the midpoint of PQ we have here. So here you write the equation of given plane is the equation of given plane is 3x minus 2y minus 4z minus 14 equals to 0, and you take this as equation 1. Okay. The direction ratios of normal to the plane are, so the direction ratios normal to the plane are here 3 minus 2 minus 4. 3 comma minus 2 comma minus 4. Okay. Let Q be the image of point P, that is 1 comma minus 1 comma 5 in the plane 1. Okay. This PQ is the image of the point P on the plane. Here whatever it is there, plane, that plane is Q here. Okay. So we have to find the Q value. So the equations of the line PQ through P and perpendicular to the equations of line PQ. So from P to Q we have one line. So the equation of line PQ through P and perpendicular to given plane. Okay. So we have here it is 1 comma minus 1 comma 5, and Q we are taking as x1, y1, z1. Okay. And this is the plane. So that means whatever PQ line is there, that is perpendicular to the plane. Okay. So now here either you can take x1, y1, z1, or else you can take x comma y comma z also. So why? Because x is not there, no, you can take x comma y comma z. So we know the line equation when direction ratios are there here 3 minus 2 minus 4, and PQ is a line, that is x minus x1, y minus y1, z minus z1 by L1, M1, N1. That is the line equation. So the line equation is x minus 1 by first the direction ratios is 3. It is equals to y plus 1 by minus 2 is equals to z minus 5 by minus 4. Okay. This is the line equation we have when PQ is perpendicular to the given plane. Okay. Now let x minus 1 by 3, y plus 1 by minus 2 is equals to z minus 5 by minus 4 equals to r. Okay. So we need to find x, y, z values, no? So for that purpose, we are taking it as equals to r. Therefore, the coordinates of r are the coordinates of q are, when you do the cross multiplication, 3r plus 1 minus 2r minus 1 minus 4r plus 5. So able to see, no, minus 4r plus 5. Okay. These are the coordinates of q. So we know the coordinates of P and we know the coordinates of R. Okay. So we have to find the point, that is the Q point. That means we have to know the R value here. If you know the R value, then we will know the coordinates of the Q. So here we are taking one point R as the midpoint of P and Q. We know P value point is there, Q value it is there. So R is the midpoint, means Midpoint formula is x1 plus x2 by 2 plus y1 plus y2 by 2 plus z1 plus z2 by 2. So we know this and this. So R value will be this value and this value divided by 2. Okay. So the midpoint of PQ is equals to the midpoint of PQ is equals to R. It is equals to. So what is Q? Q is 3R plus 1. 3R plus 1. And first P first point of the coordinate is 1. So plus 1 by 2, comma. Next minus 2R minus 1. Next coordinate is minus 1 by 2. Next minus 4R plus 5. It is minus 5 by 2. That is x1 plus x plus x1 by 2, y plus y1 by 2, z plus z1 by 2. Okay. Plus 5 plus, no, it is x plus x1. So minus 2r minus 1, that is minus 1. Here also you will get less. Okay. It is not minus, no, x1 plus x2. So it is equals to 3r plus 2 by 2. And it is minus 2r minus 2 by 2. It is minus 4r plus 10 by 2. Okay. This is the point for R. This is the R value, this is the Q value, and this is the P value. Okay. So now the main aim is here to find the R value. Okay. So substitute this, whatever the R value is there, that R value substitute in the plane. So then you will get the small r value. If you substitute the small r value in Q, then you will get the image of point P. Okay. If this point lies on R, you can write if R lies in given plane 1, then that is plane is what? It is 3 into 3r plus 2 by 2. Next what we have, minus 2 into minus 2r minus 2 by 2. Minus 4 into z. What is z value? Minus 4r plus 10 by 2. Next constant value is minus 14. Minus 14 equals to 0. Okay, we are substituting that r in the plane equation. So now 3 3s are 9r plus 6 by 2 minus into minus plus 4r minus into minus plus 4 by 2 minus into minus plus 16r minus 4 tens are 40 by 2 minus 14 equals to 0. Now we do the cross multiplication. So you will get it as 9r plus 6 plus 4r plus 4 plus 16r minus 40 minus 14 to the 28 equals to 0. So 9r, 9, 10, 13. 13 means 29r. 29r. Next constant values. This is 68. 68. 6 minus 68 is there, plus 10 is there. So minus 58 is equals to 0, implies 29r equals to 58, implies r equals to 2 value. Okay. So now if you substitute this r value in the Q, then we get, so coordinates of Q, what is there? 3 into 2 plus 1. Next minus 2 into 2 minus 1 minus 4 into 2 plus 5. So 4 into the 6 plus 1 minus 4 minus 1 minus 8 plus 5. So this is 7 minus 5 minus 3. Okay. Is the therefore the image of point P is therefore the image of point P is Q. This 7 minus 5 minus 3. Okay, like this we have to find the image of any point which is lying on the plane. One plane will be given and one point is given. If you want to find the image of that point on the plane, this is the procedure. Okay, so in some cases line equation will be given already, means P, Q, whatever it is there, that line equation will be given, and also you will ask to find the image of that line. Okay, so for that also you have the same procedure we need to find. So by this we are completing the unit 4. So in this 10 marks question we have covered 2 problems and 2 5 marks questions also we have covered. Okay, now we'll go to the unit 5. So unit 5 we have the important one. This is a regularly asked question, that is find the shortest line segment between the 2 lines. So that is we'll find the shortest line segment for the 2 skew lines. 2 skew lines are the 2 non-coplanar lines. 2 non-coplanar lines are called as the skew lines. The 2 non-coplanar lines which do not intersect. They will not intersect at any point. Such type of lines are called as skew lines. For the skew lines, we have to find the line which is the short. For the 2 lines, we have to find the shortest line segment here. So for that, you have the procedure in your textbook, if you'll see. So for solving this problem also, you have 3 methods are there. So you can adopt any one method for solving the problem, which is easy for you. You can solve by using that method. Okay. So first method is the somewhat direct method, means with the help of the formula, we can find here. If you remember those formulas, we can find the shortest line segment. He will ask, and also he will ask to find the 2 equations of the plane also with the help of the shortest line segment. Okay. So 3 methods are there. You check those 3 methods. We'll see first method. And here also for finding the shortest line segment, the question will be for means in the question the lines, 2 lines we are taking. No, the 2 lines may be in symmetrical form or may be in unsymmetrical form. So whenever symmetrical means direct method we can adopt. When it is in unsymmetrical form, again 2 methods will be there. One, you can convert the unsymmetrical into symmetrical, and you can follow the first method, and directly with the help of the unsymmetrical only by taking lambda, you can find the shortest line segment. Okay, that is with here for coplanarity we'll take lambda. No, here we'll take r and r dash. But for combining the 2 unsymmetrical line equations, we'll take one as r and another as r dash. And we have to find r and r dash values, and we have to check the shortest line segment between those 2 line equations. Okay. So first method procedure you have in your textbook. It is in page number 129. 2 line equations whenever they are in symmetrical form. So like this, few lines will be there. They do not intersect each other. Okay, this is A, B, one line, and C, D is another 2 lines, another second line, and here whatever the G, H is there. Okay. This is the shortest line segment of the so here G, A, B and C, D are 2 few lines. Okay, and here G, H is the shortest line segment between the 2 skew lines. So we, for all the problems, we need to find the GH value Okay. So for this one, 5.2.1 page number, if you see there, the procedure is given. Let the given lines A, B, and C, D have the equations. So they are in the symmetrical form. So where A value is x1, y1, z1, C value is x2, y2, z2. Let L comma M comma N be the direction cosines of the line segment GH. Since GH is, if you'll see, this GH is perpendicular to CD. GH is perpendicular to both AB and CD. We'll get whenever two lines are perpendicular to each other. In the first unit, we have seen the condition of perpendicularity, that is L into L1 plus M into M1 plus N into N1 equals to 0. So with the help of that, you'll get two equations. From those equations, if you'll do by the cross multiplication method, you will get M and L, M n values. So that if you substitute, you will get the L, M, n values. So for finding the shortest line segment, formula is L into x2 minus x1 plus M into y2 minus y1 plus N into z2 minus z1. Okay. So when you substitute all the values in this one and when you simplify, you'll get the shortest line segment. After getting the shortest line segment, here two formulas are there, second and third equation you have. Whenever you substitute that line equation here, x minus x1, y minus y1, z minus z1, L1, M1, N1 and L, M, N values. And if you'll do the simplification with the help of finding the determinant, you will get the two plane equations which they lie in these two given line equations. Okay, this is the procedure for finding the shortest line segment for the given two few lines. So we'll see one problem on this. Okay, it is the MEQ question in page number 150. You have this one. Okay. Page number 150 you have. So find the length and the equations of the shortest line segment. So you can write this as shortcut SL. Yes, okay. Between the lines, okay, two lines are x minus 3 by 1 is equals to y minus 5 by minus 2 is equals to z minus 7 by 1. And the next one is x plus 1 by 7 equals to y plus 1 by minus 6 equals to z plus 1 by 1. Okay. Find the points where it meets these lines. Okay, that is x1, y1, z1, x2, y2, z2. The point we have to find that one. Okay, so the question is find the length. Length in the sense it is the shortest line segment, whatever the length is there, that length we have to find, and the equations of the shortest line segment between the lines. These are the two given lines. First thing is that, and we have to find the equations also for this one. And the equations is there now in the question. First we have to find the length, after that equations, after that the points in which these two lines meet. Okay. So in the solution, first you write that let the given lines be, and write this as equation 1 and equation 2. So in this only I am writing. Okay, let the given lines be. This you take as 1 and this you take as 2. Okay. These are the two given lines. So let L comma M comma N be the so it is in page number 150. You have let L comma M comma N be the direction cosines of let L comma M comma N be the direction cosines of line of shortest segment between 1 and 2. Okay, between 1 and 2. Since shortest line segment is perpendicular. Through the diagram just now we have seen shortest line segment will be perpendicular to both AB and CD lines. Okay. So whenever they perpendicular means the condition of perpendicularity here we have to apply. Is perpendicular to 1 and 2. We have that is also we can write or we have these. So these are L1, M1, N1, L2, M2, N2. And here LMN are the direction cosine. So L into L1. So L into L1 means L into 1. So you will get L. Next M into minus 2. That is 2 minus M. Next plus N equals to 0. So this is through this one. Now next this one means 7L minus 6M plus N equals to 0. Okay. These two are the two perpendiculars for line 1 and 2. Now we have to solve these LMN with the help of the cross multiplication method. Solving these by cross multiplication method. Okay. So we know that minus 2, 1, 1, minus 2. Minus 6, 1, 7, minus 6. If we do the cross multiplication, we will get here L, M, N. Okay. So L by minus 2 plus 6 is equals to M by 7 ones are 7 minus 1 equals to N by minus 6 plus 14. Okay. L you will get by 4 is equals to M6 equals to N by 8. 4, 6, 8 we got. We can cancel out these 3 with the help of 3. So you'll get it as L by 2, M by 3, N by 4. So LMN values here are 2, 3, 4. Okay. So if you see in the textbook, the procedure for finding the LMN values is that is LMN values, it should be equal to 1 divided by under root of, that is here you will get L square plus M square plus N square. First unit, if you'll see for finding the direction cosines, that is LMN is equals to L square plus M square plus N square under root of L square plus M square plus N square. Okay, LMN square means that value is 1 from the first unit. Okay, and if you do the square of 2 square, 3 square, 4 square means you will get some value here. So this is equals to so this is equals to L by 2 is equals to M by 3 equals to N by 4 is equals to L square plus M square plus N square by root of L square plus M square plus N square. So this L square plus N square plus N square value is 1. Okay, we know that from the first unit. And here root of L square, L value is 2 plus 3 square plus 4 square. Okay. So this is 1 by 4. This is 9 plus 16. 16 plus 4, 20, 29. So we'll get it as root 29. Okay. So now therefore plus or minus, we will have this formula is for plus or minus. Okay. So therefore L is equals to plus or minus. If you do the cross multiplication, it is 2 by root 29. M is equals to plus or minus 3 by root 29. And N is equals to plus or minus. If you do the cross multiplication, 4 by root 29. Okay. So here we got LMN values. So whenever you will get the LMN values, we need to find the shortest line segment between that. So for finding the shortest line segment, the formula is L into x2 minus x1 plus M into y2 minus y1 plus Z into, plus N into Z2 minus Z1. Okay, that is the formula for finding the shortest line segment. So a point on line 1 is, so we have the first line equation, no? From that, the point on the line 1 is 3, 5, 7, and on line 2 is, that is x1, y1, z1, x2, y2, z2 values. It is -1, -1, -1. Okay. The point on 2 line is this one. The length of shortest line segment is the length of shortest line segment is the projection of join of points 3, 5, 7 and -1, -1, -1. That is the formula we have on shortest line segment. Hence, the formula is L into x2 minus x1 plus M into y2 minus y1 plus N into z2 minus z1. Okay. So here what is our L value? L is 2 by root 29. These are x1, y1, z1. This is x2, y2, z2. Okay. x2 means -1, -3 plus what is M value? M is 3 by root 29. y2 -1, -5 plus 4 by root 29. z2 is -1, -7. Okay. So this is 2 by root 29 minus 4. This is 3 by root 29 minus 6 plus 4 by root 29 minus 8. If you multiply this, minus 8 by root 29 minus 18 by root 29 minus 32 by root 29. So all the denominators are same, no? So minus 8, minus 18, minus 32 by root 29. So what you will get? 8 means 3, 4, 5, 50. 58 you will get. That is minus 58 by root 29. Okay. This here you are getting the negative value, no? So here you can write it like this, x1 minus x2 also we can take. So you will get the same one. That is x1 minus x2 means 3 minus of minus. So we will get plus 3 plus 4, 5 minus of minus means you will get the all positive values you will get. So length, whatever it is there, it will be not there in the negative value. So you can take here the modulus of this one or else. So your modulus of this means you will get it as 58 by root 29. Okay. So 58 by root 29 means shortest line segment will be. So length will be not in the negative signs. Just you interchange this one. This x2 minus x1 you have done, no? You can do x1 minus x2 also you can. Or else keep like this only, you take the modular. So it is 58. You can write 2 into 29 by root 29. It is 2 into root 29 into root 29 by root 29. So root 29 will get cancelled. 2 root 29 is the shortest line segment of the, that is the length of the shortest line segment for the given two lines. So length value is 2 root 29. Okay. So now in the second one, first thing is we have to find the length, and second thing is we have to find the equations. For finding the equations, The formula we have direct to that one. X minus x1, y minus y1, z minus z1 by Lmn, and after that L1, M1, N1. Okay. So the equation of plane containing one and shortest line segment is, okay. First equation, x minus x1, y minus y1, z minus z1. L1 M1 value is 1 minus 2, 1. And shortest line segment LMN values are 2 by root 29, 3 by root 29, 4 by root 29. If it is equals to 0. Okay. So we know that this is x minus 3 minus 4 to the 8. 8 by root 29 minus 3 by root 29 minus of y minus 5. 4 by root 29 minus 2 by root 29 plus z minus 7 into 3 by root 29 minus of minus plus 4 by root 29. So if you simplify this one, you will get the equation as 11x plus 2y minus 7z plus 6 equals to 0. Okay. So do the simplification further. This is one of the equation of the plane between the line 1 and between that is the shortest line segment. And second line equation is, that is next equation of plane containing 2 and the shortest line segment is, second one is x plus 1, y plus 1, z plus 1, 7 minus 6, 1. This is 2 by root 29, 3 by root 29, 4 by root 29. Okay. So when you do the simplification for this one, you will get the plane equation as it is equals to 27x, 26y minus 33z plus 20 equals to 0. Okay. This will be the plane equation. Just as usual, we have to find the determinant of this one. And he is asking third one is the finding the points. Find the points where it meets these lines, means these points are nothing but x1, y1, z1 values and x2, y2, z2 values. Those are only the points. Okay. Last one, therefore, the points where these lines meets are, that is 3, 5, 7, minus 1, minus 1, minus 1. Okay. So like this, you have to solve the problem for finding the length and finding the equations and finding the points. Okay. So this is the first method I have told. For this problem only, you can do with the help of the second method. Second method is taking the line 1 equals to R1 and taking the second line equal to R2. And if you do the cross multiplication, we'll get the 2 points P and P dash. So the direction ratios of P and P dash means you have to subtract those 2 points. And this procedure also given in the textbook, second method. And even third method is also there in the textbook. See the third method also. So in this also, in MEQ questions only, you have 4 line equation, that is 4 plane equations are given. In that 2 plane equations, they combined belong to the 1 line equation, and second and third and fourth, whatever the plane equations are there, they combine and become the second line equation. Okay. By all the whatever the line equations are given, they are in the unsymmetrical form. So for the unsymmetrical one, we have to find the length and also equations we have to find. Okay. So for this, one method is converting the 2 unsymmetrical forms into symmetrical form, and whatever the we have done first method problem, the first problem, direct with the help of the formulas, we can find the solution. Or else One more method is there. By taking first line equation, we have to add two planes with the help of lambda and other two planes with the help of mu, and we have to find that lambda and mu values. Somewhat it will be the lengthy process, so we'll see that problem in the next week, and after that we'll go to the block 3. So block 3 is about the sphere we have. Okay, before that, try to practice the problems from the test book. Okay, we'll see in the next class.